In this video, let me consider one example on system transfer function. An LTI system has impulse response h of n is equal to 0.5 power n u of n. Determine the input to the system if the output is given by y of n is equal to 0.5 power n u of n plus minus 0.5 power n u of n. So in this numerical, the system impulse response h of n is given and output y of n is given. We are supposed to calculate h of x of n, that is input. So we know that the LTI system having impulse response say h of n, suppose the input is x of n and the output is y of n. If we take the z transform of this, then the input will be x of z. The z transform of h of n will be h of z and the output will be y of z. In that case, I can write here h of z is known as system transfer function, which is given by h of z is equal to output by input, that is y of z divided by x of z. So in this numerical, y of n and h of n is given. We are supposed to calculate h of z, that is z transform of h of n, and z transform of y of n will get y of z. Then with the help of h of z and y of z, we are supposed to calculate x of z. So here from this I can write x of z is equal to y of z divided by h of z. We'll call it as equation 1. So now we'll try to find y of z and h of z. So here h of n is given as h of n is equal to 0.5 power n u of n. So we'll try to find the z transform of this, that is h of z is equal to summation n is equal to minus infinity to infinity h of n z power minus n, or I can write it as summation minus infinity to infinity h of n is 0.5 power n u of n z power minus n, or I can write it as, here u of n indicates that the signal is right sided signal, that is the signal value is 0 for n less than 0. It means that n varies from 0 to infinity. N is equal to 0 to infinity 0.5 power n z power minus n, or I can write it as summation n is equal to 0 to infinity. I'll try to take n as a common power as 0.5 z inverse raised to n. We know that summation n is equal to 0 to infinity alpha power n is equal to 1 upon 1 minus alpha. Here alpha is nothing but 0.5 z inverse. Therefore, h of z is equal to 1 upon 1 minus 0.5 z inverse. Thus we found h of z value. Now we'll try to find the z transform of y of n sequence n. Let's calculate the z transform of this. So z transform of y of n is y of z, which is equal to summation n is equal to minus infinity to infinity y of n z power minus n, or I can simplify this as summation n is equal to minus infinity to infinity y of n value is 0.5 power n u of n plus minus 0.5 power n u of n, we have z power minus n. So now by applying linearity property, I will try to apply this summation as different terms, that is summation n is equal to minus infinity to infinity 0.5 power n u of n z power minus n plus summation n is equal to minus infinity to infinity, here we have minus 0.5 power n u of n z power minus n, or I can rewrite it as, here u of n means the signal varies from n equal to 0 to infinity, that is right sided sequence. n is equal to 0 to infinity 0.5 power n z power minus n, plus similarly here also n is equal to 0 to infinity minus 0.5 power n z power minus n, or I can write it as summation n is equal to 0 to infinity 0.5 z inverse power n, plus here also I can write it as n is equal to 0 to infinity minus 0.5 z inverse raised to n. So the value of this is 1 upon 1 minus 0.5 z inverse, plus here its value is 1 upon 1 plus 0.5 z inverse. So let me simplify this further. Let me write here. So further I can represent it as y of z is equal to, I'll take the LCM as 1 minus 0.5 z inverse, and another term is 1 plus 0.5 z inverse. So this term will be represented here 1 plus 0.5 z inverse plus 1 minus 0.5 z inverse. Simplifying this, y of z is equal to, we have 2 divided by 1 minus 0.5 z inverse, and we have 1 plus 0.5 z inverse. X of z is equal to y of z divided by h of z. That is, so y of z value is given by 2 divided by 1 minus 0.5 z inverse 1 plus 0.5 z inverse, and divided by h of z. H of z value is given by 1 upon 1 minus 0.5 z inverse. So I can represent it as into 1 minus, I'll take denominator as numerator, it will become minus, it will become multiplication 0.5 z inverse divided by 1. Therefore I can write x of z is equal to, so here this term and this term will get cancelled, will get 2 divided by 1 plus 0.5 z inverse, or I can rewrite it as 2 divided by 1 minus 0.5 z inverse. The ROC will be z is greater than 1 by 2. It indicates that the signal is right sided signal, that is causal signal. So I can now, to find x of n, we are supposed to take inverse z transform by taking inverse z transform. We will get x of n, that is inverse z. We know that the z transform of alpha power n u of n is given by 1 upon 1 minus alpha z inverse. So comparing this expression with this expression, here the value of alpha is minus 0.5. Therefore inverse z transform of x of n, x of z is x of n is equal to 2 is constant, keep it as it is, alpha power n, alpha is minus 0.5, minus 0.5 power n u of n. So this is x of n. This is input of the LTI system. Thank you for watching.